and it's a function of x, and x is just the variable. So we differentiate both sides. When we differentiate the first, it's a function to the fourth power prime, 4p to the third times the inner function prime. You always have to say times the inner function prime plus the inner function prime, there is nothing else, minus 3 equals 0. See if you have any questions on this. Before I forget, I'm kindly asking you to complete the survey. You get 5 points on the final exam, 5%, which is a huge boost to your final exam grade. It's basically, I know, I feel the same. Not another survey. Don't hit me with another survey. I know. But I'm supposed to and kindly ask you to remind you every time we meet till the end of the class. Okay? So if you don't mind, my boss looks at this, I look at this. If you have suggestions for me, I will always pay attention to your note. Okay, so now we have to find dp over dx, but these are not like terms, so I have to factor out dp over dx and move 3 to the other side. All I have to do next is dp over dx equals 3 over 4p cubed plus 1. And that's all I needed to do. So we differentiated implicitly, and because we could not combine like terms, 4p cubed times a variable plus the variable, these are not like terms. I have to factor out the variable, which is dp over dx. Any questions on 11? Okay, 12. We are given, so this is basically the same problem. So y equals 2x squared plus x. They're asking us to find dy over dt when x is -1 and dx over dt equals 5. So when you see this problem and you look at it carefully, you will understand that both y and x are function of a third variable. So I'm going to put a dot underneath to remind me that none of these is a variable. Y is not a variable. Y is a function of t. X is not a variable. It cannot be treated as a variable. It's a function of t, a different function of t. So now again, I differentiate implicitly. The left-hand side is dy over dt. The right-hand side is 4x times the inner function prime plus the inner function prime. What is different from the previous case is that here x is the variable as well, and I'm asked to evaluate something. Good. So I'm asked to evaluate dy over dt. I'm done. All I have to do is replace x by -1 and dx over dt by 5. It's done. So dy over dt equals 4 times -1 is -4 times 5 plus 5. -20 plus 5 is -15, and it's done. Any questions on this? Anybody? Okay, moving on to 13. Okay, a circle is growing, its radius increasing by 3 millimeters per second. So if you want to use r for the radius, you will immediately write dr over dt equals 3 millimeters per second. dr over dt, a circle is growing. Its radius is increasing by 3 millimeters per second. Find the rate at which the area is changing at the moment when the radius is 14. So they want us to find dA over dt when r equals 14. All I have to remember is that the area is pi r squared. I put a dot underneath and a dot underneath. Why? Because the area is a function of time, radius is a function of time. So this is an identical situation with this. It's just that I'm not given the formula, but the rest is identical. So A is a function of time, R is a function of time. When I differentiate implicitly, I have the inner function prime equals 2 pi r times dr over dt. So I'm differentiating a function to the second power. I bring 2 in front, I subtract 1 from the power, and I always have to say times the inner function prime. I have everything. So I have this, which is 14, and I have this, which is 3. So if they want the exact, I will multiply 14. So if with the graphing calculator, if they want the exact, I will say 28 times 3. And I put 84 pi. But if they want us to approximate, I will multiply by pi to 63.89. So to 63.89. And remember, this is the area. So is millimeters squared per second, or is 84 pi millimeters squared per second. So dA over dt, dA over dt. So if they want an approximation, and if they want the exact is 84 pi, the approximation is 263.89. The measurement units must be 2 measurement units because it's a rate of change. 1 measurement unit coming from the area, and the other one coming from the denominator, which is time. Always remember, we don't drive at 60 miles. We drive at 60 miles per hour, which means the rate of change. Good. So it says round to the nearest thousands. Careful, which means they want 3 decimal digits. I only wrote 2. So in this case, I would write 263.894. 263.894. Good. Let's look at 14. The same thing. dA over dt, dB over dt is the same problem. A cubed plus B cubed equals 65. Same idea. And they want us to find what is the rate of change of dA over dt at the moment when A is 4. And dB over dt equals 3. Good. So again, we differentiate. And because we are talking about dB over dt and they want us to find dA over dt, I will put a dot and remember that A and B are not variables. They are functions of time. So then I have 3a squared dA over dt plus 3b squared times the inner function prime equals 0. I would simplify both sides by 3. I will divide both sides by 3. So then I have a squared dA over dt equals negative b squared dB over dt. And since they want us to find dA over dt, I will divide by a squared. So dA over dt, so we divide by a squared. equals negative b squared over a squared times db over dt. We are given dB over dt, this is 3, and they are giving us a equals 4. And the formula that we started with, or the equation we started with, was this. If I am given a, I can determine b. And I'm given a, which is 4 to the third. So b cubed equals 65 minus 4 to the third, which is 64. So b equals 1. Because it's b to the third equals 1, so the only real solution is b equals 1. So now I'm ready to give the final answer, meaning dA over dt equals negative. B is 1, so this is negative 1 over a squared, which is 16, and multiplied by 3. dB over dt is 3. So the only thing I can write is that dA over dt equals negative 3 over 16.
I have a question.
Please.
So it's b squared dB over dt over negative b squared time over negative a squared times dB over dt. Does it not make it positive in the end? Because they're both negative terms.
So I had this, and I had to move this to the other side, and it had positive. So when I move it to the other side, it's negative. So then I have a squared dA over dt equals negative b squared dB over dt, and I'm dividing by a squared.
I see where I messed up. Okay.
That's okay.
I got it.
So negative b squared over a squared times dB over dt. And we had to determine b. They were not giving us b. They were giving us only a. So we determined that b was 1. So when I plug it back in, 1 squared, so the negative stays because I can only square what b is and what a is. I cannot include the negative in front.
Yeah, that's what I was doing. I was
Yeah, I know.
with the negative.
No, you cannot, because we don't have parentheses.
Thank you.
Thank you. Very good. Other questions here? Anybody? Okay, this was, I think it was 14. 2 more here. Find the linearization. These are just simple formulas that I hope you will remember. So the linearization of a function is f of a plus f prime of a x minus a. This is just a formula, and that's all we need to use. So we are given f of x equals 7x squared, and they want us to find the linearization at a equals 2. So obviously I have a lot of information already. So this is f of 2. This is x minus 2. And I have to find f prime and plug in 2 as well. So f prime of x equals 14x. And I also have to find f prime of 2. So f prime of 2 equals 28. F of 2 is also 28. 7 times 4. So I'm done. I just have to plug them in. So L of x equals 28 plus 28x minus 2, and I have to distribute. So L of x equals 28x minus 28 times 2 plus 28 is minus 28. And this is it. This is part A. just determine the pieces from the formula and just plug them in. Then it says, use a linearization to approximate 7 times 2.1 squared, and then find 7 times 2.1 squared using a calculator, and what is the difference? Okay. So in part B, they want us to find L of 2.1. It was, yes. In part C, they want us to find F of 2.1. And in part D, the difference, delta F. Or let's write just difference. Good. So in this function, I will plug in 2.1. In the original function, I will plug in 2.1 and then calculate the difference. I highly recommend to do this. Go to the graphing calculator. In y equals, put 28x minus 28. Do not do this separately and by hand. There is no need to do something like that. And 7x squared. It's better to see them side by side and just plug in 2.1. That's all you need. So the first one, which is the approximation, is 30.8. The other one is 30.87. So then the difference is 0.03. 7, sorry. It's 30.87 minus 30.8. So it's 30.87 minus 30.8 is tiny difference of 0.07. And I think there is one more problem here. Yes, so we are given the revenue and the cost. They want us to find the profit. They want us to evaluate all of them at 150, determine the marginal revenue, cost, and profit, and evaluate all of them at 150. Any questions before we look at the last problem in test 2? Anybody, any questions? So when you see a problem worth 1 point, you will know that this is the extra credit. So the system does not allow me to create a problem with 0 points. So the minimum is 1. No problem will be worth 1 point. So when you see 1 point, it means that that is the extra credit. And I will definitely add 9 points to your test grade if you solve the problem correctly. Okay, so let's take a look. Let's copy the revenue and the cost. So the revenue and the cost. I'm copying, so that's 7x, very easy. 0.005x squared plus 1.9x plus 70. And they want everything at 150. Good. So the profit function, please remember it's 7x minus every piece in C of x. Every piece, every term from C of x has to be subtracted. And yes, I will combine my terms when possible. And then I have plus 5.1x minus 70. I will enter all these 3 functions in the graphing calculator and I will plug in 150. There is no need to do it separately. So put everything in the calculator in y equals. And I will also put in let's also calculate the marginals and then put all of them. So r prime of x is 7. C prime of x is 0.01x plus 1.9. And of course, p prime of x is negative 0.01x plus 5.1. So I will enter all 6 functions in the graphing calculator because I need to plug in 150. And I will have everything in a blink. So, first 7x, then 0.05005 x squared plus 1.9x plus 70. And then negative 0.005 x squared plus 5.1x minus 70. And now the derivatives, the marginals, 7. There is nothing I can do to that. I shouldn't even put it in, but let's say 0.01 x plus 1.9. And the last one is negative 0.01 x plus 5.1. Good. Okay, and all I have to do is just plug in 150. And just copy everything across. 1050, 467.5, 581.2. These are all dollars. But now from 7 on are dollars per unit. $7 per unit, $3.4 per unit, $3.6 per unit. The marginals are rates of change, so they all have 2 measurement units.